Okay, good morning everyone and welcome to our talk Get Reactive. This talk is about RxJava, about reactive extensions on the JVM. And in the first part of the talk, I'm going to give you an introduction to the base concepts of RxJava. And later on, Pascal is showing you how to apply those concepts on Android. Now, reactive extensions were created by Microsoft for the .NET world and were ported over to the JVM by Netflix. And this is a quote of the GitHub page. RxJava is a library for composing asynchronous and event-based programs using observable sequences for the JVM. Now, what does this mean? I think this graph here depicts this nicely. It's inspired by Ben Christensen of Netflix. On the very left of this graph, you have sources of events, sources of data coming in. Could be a network, could be your database, could be a list or some object that you have available in your code. And as you can see, this is a timeline. The items are dropping in and going to the right. And each colored shape is one item of data that was emitted by an observable. Those observables are, let's say, a wrapper for those data sources. And those rectangles are the operators that operate on the observables. They manipulate them or combine them. As you can see on the top, there are two observables that get combined together, or below the triangle gets flipped upside down. And at the very end, you just have one observable left, and it's of type cloud. And this is what you're really interested in. So you combine all the data coming in, or that you have available in some way. We will show you how to manipulate them. And at the very end, you subscribe to the data of a certain type that is really meaningful for you at this point in the program. Now, first, let's see some code. This is a simple observable. At the very top, you create the observable with observable from. It can take a list of objects, it can take an array, and it emits those items. And below this are three operators. The first operator is the filter operator that throws away one of those items. Then there's the count operator that counts the remaining items in the stream. And then the final operator, the map operator, moves this integer to a string. So you go originally from an observable of 4 integers to an observable of string at the very end. But what you see here is not the execution, it's just the definition, the declaration of what you want this observable to do. Nothing happens as of yet. It only starts to happen when someone subscribes. It's comparable to Java 8 streams, where you the stream only runs when someone consumes it. But in contrast to Java 8 streams, you can subscribe to this observable multiple times, and it works. And streams you can only consume once. Now, this is a simple subscriber. At the very top, you subscribe to your object with the subscribe method, and you get passed in a subscriber object. And this has 3 methods. The most important one is onNext. This method will be called whenever one item is ready for you. And those other methods are called either when no more items are to be emitted anymore, that's uncompleted, or when something goes wrong, onError will be called with the exception that was, or the throwable that was thrown. Now let's see some of those concepts in more detail. First of all, of course, you need to have an observable available for you. You have already seen this observable from call. You could also use observable just, where you can put in arbitrary objects from 1 to 9 objects, and exactly those objects are going to be emitted. You can create a range of integers. You can create observables that emit an item at a certain point of time. You can create observables that emit items at certain intervals. And of course, you also can create your custom observable. say you want to wrap your cursor in Android, you could do this with Observable create. And Observable create is not necessarily the operator or the creating operator you use the most, but it's the most interesting one. So I'm going into a bit more detail about this one. So again, at the very top, you have this Observable create. It's a static method, and it gets an object of type onSubscribe, and this object has a callback, which gets past the subscriber. And the subscriber, if you remember this initial graph, is not necessarily the subscriber at the very end, but any operator is a subscriber to the observable. Now, and within your create method, then you call those callback methods to the subscriber. You call on next whenever an item is ready. Say when you are in the next row of your database, you call as on completed when you're done with it, and should anything go wrong, you should call as on error. Now, this is way too simple because a subscriber, when it subscribes, gets back a subscription object, which the subscriber can use to cancel the subscription. Say you have an endless stream of items coming in, the subscriber at one point of time wants to tell you that it's done with it. And so you should always check if your subscriber is still subscribed. So wrap every emission of objects, every callback method with this check if the subscriber is unsubscribed, then do not emit anything, do not call on completed, do not call on error, just break out of the loop and end this method. So when you have created your observables, of course, you also have to consume those. You've already seen the subscriber itself. There are multiple overloads for subscribe, where you can pass in some lambdas to just use the stuff you're really interested in. Say you're not interested in the uncompleted callback, you would just pass in 2 lambdas instead of 3, for example. But the important part here is that you should not leak anything. Especially on Android, we have very limited memory, and it's important not to leak anything. And so I've shown you an anonymous inner class for the subscriber. You should consider to use static inner classes instead, and you should use this subscription object that you get back to unsubscribe. So at the very latest, in the onDestroy method of Android, unsubscribe from your subscription. There is a project, RxLifecycle, that helps you to do that so that you do not have to care about this yourself. The most interesting part of RxJava, though, is how to get from those initial events to this certain data type that you're interested in, to the cloud in the initial graph. And you have all kinds of operators in RxJava. I think there are about 150 operators available, and you can also create custom operators should those not suffice. And with the operators available, you can transform the items emitted so that they're of a different type. You've already seen this map method where I transformed from an integer to a string. You could filter elements so that the total number of items emitted will be reduced. You could use conditions so that items only get emitted when a certain condition applies, or that items start emitting when a certain condition applies. And of course, you've seen this in the initial graph, you can also combine different observables to just one observable that you're interested in, and you can aggregate them. You've already seen the count method, but you could also return all items in the observable as a list, for example, or convert the observable to a map. Now let's see 3 operators in more detail. Now first of all, this is a marble diagram. Every operator of RxJava is documented with these marble diagrams. The RxJava documentation is really very good. And at the very top of those diagrams, you have the source observable, and those colored shapes are the items emitted. In the middle of the diagram, in this box, you have the operator, and at the bottom, you have the resulting observable. And you've already seen this flat map where you went from one object type to another object type. And flat map allows you to do something similar, but as you can see in the operator, flat map, the function you're using within flat map returns an observable of items of some type. And if you would just use this, you would end up with an observable of some stuff. And that's not what you're interested in. You want an observable of this some stuff. So what flatmap does is it gets rid of this inner observable and merges all the items within this that are emitted within these inner observables. As you can see here at the bottom, it's really emerging. It's not that first all red items are emitted, then all green, and then all blue. But the green and blues are intermixed with one another. And often you have an API where you can use observables, say Retrofit, for example, that allows you to get your network calls, your network results back as an observable of a specific type. Then you would use flatmap, for example. Now this is a combination operator. You have two observables at the top, and of course one remaining observable at the bottom, and it always combines the latest items of each of the observable. It can only start emitting items when both have emitted items, but afterwards it always combines the latest. So that's why you have three diamonds at the bottom, and then you have another shape, but have still the same color, because the color is still coming from the item before, at the top observable. Contrast that with zip operator. It also combines two observables, but it does so by keeping the position. So it combines always the first item of the first observable with the first item of the second observable, and then the second item of the first observable with the second item of the second observable, and so on. And you can imagine that this might lead to problems if the first observable, for example, emits items much faster than the second observable. You run into a problem that's called backpressure. This basically happens when one observable produces items too fast for the subscriber to cope with that. And you have to deal with this, obviously. So there are different ways how you could do so. One way is to simply drop items. So you could take just one item every 100 milliseconds, for example. Another is to specifically request a certain amount of items that you know that you can cope with from your upstream operator, and then the upstream operator will only emit as many items as are requested, then waits with emitting until more items are going to be requested by the downstream operator. And this request hasn't been supported by the initial create method that I've shown you. If you want to support this request operation, you would have to use a producer, and it gets fairly complicated. If you want to deal with that, or if you want to read more about that, I recommend to first go to the wiki page of the RxJava project, start there, and then go on to the blog Advanced RxJava, which covers creating operators and creating observables in much more detail, and covers backpressure fairly well. Now, so far, everything that you've seen is running on the same thread, and most likely that's not what you want to do, especially not on Android, but not only on Android. And to move stuff to another thread, RxJava uses schedulers. Schedulers simply define a strategy to select a thread where stuff runs on. So there are different strategies. For example, schedulers I/O can be used for I/O bound tasks, for blocking tasks, and it selects a thread of a growing thread pool. Scheduler's computation, in contrast, uses a thread pool with a fixed size of threads, and the number of threads is determined by the number of cores of your CPU. And so this subscribe on call, you pass the scheduler into the subscribe on call, and the subscribe on call moves the processing chain to a different thread by using this scheduler. And the observe on call is used to move the subscription on a certain thread, so that the callbacks will be called on the main thread, which is important if you want to manipulate the UI in Android. So what you usually have is you would have a subscribe on call followed by a observe on call immediately before you subscribe to an observable. Now, error handling on RxJava allows you some options. Now, the last line is not entirely correct. It should be your subscriber. Subscriber is observer is an interface, and the subscriber is an implementation of the interface. But usually you always have a subscriber. So this on error is the callback that you've already seen. But when this callback is called, your observable is toast. You no longer can use it, and no more items will be emitted. And sometimes you do not want that. Sometimes you want other items to appear, or one last item to appear. If you want just one more item, you could use on error return that returns a special object that should be returned in case of an error, and afterwards on completed will be called. Or if you want to go on a different observable, you could use on error resumes next. So say you have an observable for a network call. It's bound to go wrong, or it could very likely go wrong. So you would consider using on error resume next to switch to an observable that uses stale data from a cache to display in the UI instead. Now, testing observables could get very ugly because of the callback methods, and you would have to remember the state somewhere in your unit test code and react to this later on. And to avoid this, RxJava provides this test subscriber object, and this test subscriber can be used by you to access all the items that have been emitted so far, to see if the error has been thrown, or to see if the observable has completed already. And you can use those special or those operators on the top to create edge cases. Say you want to test if your error handling works as expected, you could use observable error to create an observable that just calls on error directly. Or you could use an observable.empty that will call on completed directly and not emit any items. So you could test, use this, for example, to test if your code reacts properly to an empty result set in a database. And observable never will never emit any item and will also not call on completed. It just keeps on running. And you can test this to check if you cope with this situation well, and if your unsubscription, for example, works perfectly. Now, finally, you might want to debug observables, and this is also not so easily done because of the callback nature. If you set a breakpoint, say in the initial example, before the filter method, to check what's going on there, it wouldn't help you anything because the code would stop during the declaration phase of the observable. But you want it to stop during the running phase when actually the filtering takes place. And the only way to do that properly is by setting the breakpoint within the operator that you want to debug. Most likely that's not very not feasible for you. So you have other means to work around this limitation. You could use this do on next call, for example, to listen to the current state of the observable. So if you put in use a do next call within your chain of operators, whenever the observable above this do next call emits an item, it will be passed to this do next call. You can use this then to log this item, and the observable afterwards proceeds normally as it would otherwise. And then you could put in do next call after the interesting operator that you do not understand properly or that works differently than you expected. And then you would see all items emitted before and all items emitted afterwards, and could see why it doesn't work like you expected. Another thing that's interesting or might be interesting are those hooks. You can use the hooks to listen to certain events happening in RxJava. For example, whenever an observable is created, there's a hook for that. And whenever someone subscribes to an observable, there's also a hook for that. So this has been about the basics. Now let's see how to apply those to Android.
Okay. I will tell you how this works on Android, and especially with some examples. Yeah. What is RxAndroid? There's this dependency called RxAndroid. If you just write your business logic in RxJava, you don't need RxAndroid to run this code on Android. RxAndroid is a super small dependency. It only has one subscriber. There's no more logic in it. A little bit, but the main part is the subscriber. And this makes an observable run on the UI thread, the main thread, so you can manipulate the UI of Android. And I recommend adding the dependency to RxJava because it gets more frequently updates, and yeah, updates are always good. So add both to your Android project and you're good. So I will talk mostly about Android UI because Android is Java. There are maybe some callbacks to the gyroscope or something else, but it's mostly about the UI. Okay, many of you will know this code. I just find a button on my UI and set a click listener. And when somebody taps this button, it triggers an action. Super simple. Of course, we can do this with RxJava. And I show you the very first code you would write to get this. You create an observable. We saw this before. It gets a subscriber, and you need to call on the subscriber the onNext method every time the user taps on this button. So this is very simple. It also supports this unsubscribed thing. So if the consumer unsubscribes from this observable, you don't get items or you don't emit items. And yeah, the code below is just how you use this. You subscribe to the My Button click observable, and every time somebody taps on it, onNext is called, and you trigger the action. Very simple. But don't use this code in production. Yeah, here's just a hint. If you are not familiar with retro lambdas or lambdas in general, because we are still stuck at Java 7. And yeah, don't use this in production because I haven't handled unsubscribing. We heard it before. You can unsubscribe from the subscriber, and even without emitting an item, you should cancel, in this case, the onClick listener, set it to null again, but it's not handled here. If you want to see the real source code, how this should be done, you can go to RxBinding. RxBinding is a library which provides all those observables for views, and it looks like this. It calls rxview.clicks for click events, and you just give it the view and subscribe to it. But what can we do with an observable? Why do we need that? The main strength of RxJava is that you can combine observables, and you can move them up from the main thread to a different thread, or you can do everything. So here's an example. I just delay the click. I'm not sure if this is useful. And I observe this on the IO thread, so my trigger action will call on the I/O thread. So we talked about this RxBinding library. There are for every kind of view, really every kind of view, observables. Here's just an example. So whenever you have a UI element, you can use this library, and even for the support library or the Android design library, the support design library, it has a lot of callbacks. And it always gets updated and receives, if there's a new widget which is commonly used, it will get updates too. So don't write your observables for widgets by yourself, only if you have something create custom. Use this library. Okay, combining UI events. This is an example of a login view. Everyone uses examples of login views. That's why I don't use it. It's too easy. And whenever I see examples of login views, it's too easy for me. And it doesn't fit. So I built a registration view. A registration view is a little bit more complex because it may have optional fields. For example, here the user can provide a username and a password and a full name if he wants to. And this changes something. Okay, what do I want to do? I combine those observables to create a new model of my new registration model. And then I will filter if the registration model is valid. I can do everything there. Maybe I make a network call to a server, validate it there. And when it's valid, I enable the submit button. So very easy, but if you try this, it may not work. I did this personally in a project. I thought, hey, this is perfect. I need to combine the latest items emitted, and then I show the submit button and enable it if everything is filled. But it doesn't work because my filter method was never called, and I couldn't figure out why. And this is the problem of this combine latest. Combine latest combines the latest items, but if an observable never emits an item, there's nothing to combine. So this Rx full name, the full name of the user, never emits an item because it's an optional field and the user might not have given his name. So here, just a quick reminder, this is the combine latest, and you see for the first item, there is no item emitted at the bottom. Only if the second observable on top emits an item and both observables have emitted an item, it combines them and emits an item. So yeah, I saw this, and here's the quick solution. I merge my optional fields with an observable which emits an empty string. Very easy. Basically, I did this for every text view I have in this registration view. They always emit at the beginning an empty string, and I'm fine. And now my observable works as expected. It checks if the registration model is valid and enables the submit button. Okay, it's not only about UI. Most of the time the UI triggers something like a network call or a very heavy calculation. And yeah. I wrote an example. I was searching for GitHub repositories, so I created a search view, and whenever the user types something in it, I show the repositories in a list. Super simple. For the request, I use retrofit2, and it gives me nice interface with observables. It always, you can do both. You get the normal Java code, which gives you a callback, or you can get observables or even singles. And single is just a single item, and after the item is emitted, it completes. Okay. Yeah, how is this solved in the Android way? I wrote different kind of ways how to solve this. The Android way, the beginner RxAndroid way, and the RxJava way, how you should do it. So this is the Android way. I just set a listener to my search view, check if the check if the query is empty, and if it's not empty, I create my network call. And here you see the callback, and inside my callback, I check for network failure, and otherwise I check the response. If it's successful, I show my repositories, and otherwise I show an error view or an empty view. It depends. But yeah, you see a lot of callbacks. It's not good code. When I first started with RxAndroid, I would have written code like this. I first created a search view observable with this dependency I showed you before, and then I filter. Otherwise, if I have an empty text, I will not. My observable should not continue at this point. So I filter, and then I start my service to do the network call. It's the retrofit service. So it's in a retrofit service, but it could be any service, and that's why I put subscribe on here. For retrofit, it's not required. It automatically runs on its own scheduler, but here I just put it to the I/O thread. So my network call will run on the I/O thread, and when it returns in observe on, I will move my work to the main thread again and subscribe to it. And on next, so the success case, I show my repositories, and on the error case, I show an empty view. This works. This works, but it's not very good. I'll show you why. First is flat map. When I started RxJava, I first learned two operators. It's map and flat map. And basically, map is when I want one object moved to another object, and flat map if I have an object and I want to create an observable out of it. So I always used flat map. But it doesn't work in this case because it's important, the order is important of the request. So the request may take different time spans, and if the first request takes very long and the second request is very quick, I get the second request first, and then the first request, which is older and has not the better data. Flat map doesn't care about ordering, it just moves the observable to the chain and emits the item to my observable below. So I change it. There are a lot of operators, so I can use concat map, and it cares about the ordering, and because my search repositories function only returns a single item, because I know it's a network call, it shouldn't return more items. I can use this concat map without. If this would be an endless observable, concat map, I possibly wouldn't get the second observable, the data of the second observable, but I only get one item. Maybe I could change it to single, which emits only one item. Yes. Okay, this works now. The ordering is correct. I show you now on the output of my loghead. I logged it, and I saw something strange. Whenever I write searching, this is what I typed into the box, and then you see the network calls. And you see the first call here is just for the D. The second call on the bottom is for DE, for the second searching. And then I continue, and it continues requesting data. I already stopped typing, but it continues requesting data. And here at the very end, I got the final result of the last typed item, and it took me about 2.3 seconds, which is quite a long time. And during typing, I got a lot of flickering inside my list, and I don't want this, of course. The problem here is backpressure. I haven't handled backpressure, so normally if I'm typing and the network call starts, I don't want to start another network call if my first network call doesn't return or haven't returned yet. So I added throttle last and debounce to prevent that every character gets sent to the network. Throttle last works like this. You give a period of time, and at the end of this time, it emits the last item which was emitted during this interval. And debounce works like this. When you are typing and you hit a character, it waits 200 milliseconds, and if not another item was emitted during this time, it emits. And yeah, I got this questions, why have you used throttle last with 100 milliseconds and debounce with 200 milliseconds? It's UI, I tested it, it felt the best. So I wrote a lot into this text view and checked the output, and this was the best compromise between not emitting too much items, but get fast responses. And the last thing here is I added on backpressure latest, and maybe if my network call takes very long, even with this throttle last and debounce, I emit too many items. And basically, I don't want to my observable to crash, so I added on backpressure latest because I'm always only interested in the latest item. So before I do the network call, I throttle and debounce everything, and then I wait and always use the last item. I don't care about the other items. Yeah. Okay, this is my output with throttle last and debounce, and this is basically what I wanted, because I'm a fast typer, as everyone here. I wrote Devoxx, and after I stopped writing Devoxx, this debounce period started of 200 milliseconds. Then I got this network call, and yeah, got my data within 1.3 seconds. So yeah, I saved 1 second, and I saved a lot of flickering. Yeah, here's another thing. I also want to support that when I'm typing, I get immediately results while I'm typing. And because this looks like, yeah, I just wait until someone stops writing, and then I make the network request, but it's not that simple. Here's an example. I go on. I searched for Devoxx talks about. It's a repository on GitHub, and here's the while typing I also got requests. So you see the requests are not mixed, they are always one after each other. So here's the first request, I get a response. Here's another request, I get a response. I get another request, make a response. And it goes on until I reach the final request and show my data. And during this interval I also show my data, but it's not that hard flickering as I would make a network request for every type character. Yes. Here's another thing, handling errors. So what the GitHub API has one limitation. When I do too many network requests, I get an error because yeah, I do too many traffic. And this problem results in an error, and whenever an observable emits an error, it stops. So I will never do another network request. I will never update my list again whenever I get an error from the network. So how can we solve this? I will focus on this search repositories method. That's why I put it in extra method. Yeah, here is how it works. If I don't handle an error here, it emits here an error. It will go into the onError method, and then my observable on top stops with an error, and it never emits items. And this is how my search repositories method works. With my solution, I do my normal network requests and maybe put it on another scheduler. And on error resume next, we heard it before. Whenever I get an error, I return an observable instead of the error. And here I return an empty observable because my observable below or flat mapping this method shouldn't care about errors. It just should receive items. And my errors, I could them handle here in this method. So if I get an error here, I could show some UI, maybe an error screen or a dialog, I don't know. But I should not return this error or let this error through my observable. So I return observable empty, and at that point, when the observable below receives an observable empty, it stops and waits for the next item. So, yeah. I'm a big fan of RxSingle. It's one item. It only has a success and error case, not a complete case. So it's very simple and perfect. It's very perfect for a network request. So you can use this with retrofit, and just in your interface you define, instead of an observable, you define a single, and you can use it. But single has no on-complete, so single does not support observable.empty. And this is a big problem, and that's why I'm using observable with retrofit and not single. But I should use single, and I haven't found a solution for this. So I use observable empty in the error case, and it works pretty good. Another big benefit of using retrofit is you can create your, or not only about retrofit, but making network calls as observables. Because I was in a sprint review and the server was not working. And I want to show a network call and it just didn't work. Or maybe the Wi-Fi wasn't working. And yeah, I just hacked a quick solution, instead of my retrofit dependency, I use my own dependency and use observable, just put a list of data items in there, delay it to make it look real, and return this. Just for mocking, it's perfect. Yes. One thing, you should unsubscribe and unstop. So if you have your activity lifecycle or fragment lifecycle, you have to unsubscribe in some way, otherwise you would leak your activity. And maybe not an unstop. If you're using something like a location provider, you should unsubscribe and on pause. But anyway, on some point you should unsubscribe, otherwise you would leak. And there's a library by Trello. It's called RxLifecycle. So you can get events based on the lifecycle of the activity or of the fragment, and combine those with your observables. And if, for example, on pause is called, your lifecycle observable emits an item, and your view observables automatically stop emitting items and complete. You can also use, I personally use this for views. When I have views and create observables, I always use, when I emit an item when my view detaches. There's another observable of this view binding dependency I showed you. And you can write rxView.detaches, and until that, you can use the until operator, and if this observable emits an item, only if the view detaches from the window, it automatically stops. And in my projects, I personally use Model View Presenter. It helps me during configuration changes, because in my example, when I rotate the screen and I have typed something, rotate the screen and maybe rotate it back, I still want to see results. And even if I'm requesting during the configuration change, I want to see results. And yeah, that's why I use a presenter. I recommend using Mosby or Nucleus. I've used both libraries. Then I started using my own library because yeah, both doesn't fit perfectly. So I use the best of both and use it as an internal library, very small. And it just helps me to have a presenter which survives the orientation change. I do all my network requests inside of this presenter, and when a view after the orientation change attaches again to my presenter, I emit the items I received during the configuration change. Yeah. So we were very fast. Yeah, of course you can also subscribe to us. We are on Twitter, of course. And if you have any questions, we have plenty of time, I see. Please, questions. Yes, please.
I want to ask about the presenter.
Yeah, the question was, when the orientation change happens, how does the presenter survive this orientation change? Because it's normally bound to the activity. I had the same problem, that's why I was using Mosby at first, and then Nucleus, or other way around, they added support for this. It works basically how, my first implementation was I use a fragment and set it to set retain, and it automatically saves during the configuration change. And then I checked the source code, how they solved it with the fragment, how this happens. And there's a method in activity called on non-configuration instance. You just return your object there, and in onCreate you can call get non-configuration instance, and you get the object there back. So that's how I solved it. And I created my own activity which handles this by default. I give it a presenter and it automatically saves this during orientation changes. This method is now deprecated, but they mention fragment to, you should use the fragment with a retain state, but this solution also uses this deprecated method, so I don't think it's a problem using this deprecated method. Other questions? No. Thank you.